My name is Valentin. I work in support. I do performance and for 13 years I've been at VMware. I do performance and resource management. I really like sustainability, but we're not going to talk about that today here. As I said, Mark couldn't make it, but he is with you in spirit. There is a recording if you want all the Canadian goodness and a couple of sorry, I can't make it. I'm really bad at this. Apologies to all the Canadians in here. Didn't want to offend. You can watch the recording from Monday. He is there. So this is the disclaimer. This was really important on Monday because they gave us this tutorial session and I forgot that the embargo was until Tuesday. So I only realized there was an embargo going after I'd done all the slides. And then I was like, oh, the embargo is going to be lifted tomorrow morning. So what I said here is ignore every number that is here. This is tentative. Nothing is promised. So if there's a number, please don't sue us and please don't fire me. With that being said, what is new in vSphere 8? It's not long a surprise. The agenda today is, and I finally, after running for 15 minutes, I have the right energy. Topology, 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 topology. Actually, you can't see it because it's black, but I ran, so it's pretty fitting. So we're going to talk about virtual hyperthreading with latency sensitivity high. We're going to talk about vNUMA improvements. And you can take as many pictures as you want because, again, it is no longer Monday. And we talk about AutoCoresPerSocket. Does that sound good? Yeah, it sounds pretty damn great, right? I mean, I didn't hear the excitement, but I'm going to bank it on the day that it's Thursday before 2 o'clock. So, yeah, this is pretty great. So it would be really cool if you talk about this, right? But we won't. What we're really going to talk about is more important, how to capitalize VMware. 60 minutes of history and analysis. Capital VM, lowercase where. I see some people leaving. So that means we have 2 possibilities here, right? And 2 possibilities, lower uppercase, and 6 letters. That gives us 64 possibilities and 63 wrong answers. So we have less than 60 minutes, less than 1 minute per slide, better get started. VMware, lowercase m. Easy to fix. Until now you thought I was joking, right? Easy to fix, correct 2 initial capitals is right there, right? And I know a couple of VMware people in the crowd here, and you should take screenshots, or you should take pictures and change it because you have written me before, right? There is an exception list. You can put VMware in there, and guess what? It is not the default on VMware provisioned Windows laptops. Thank you very much. I deal. All right, VMware, camel case, Andromeda case. I am not happy to see this even in scripts for methods and functions, but I'm okay, but please don't use it in your emails. It makes my eye twitch. VMware, all lowercase. You think, oh, my data is close enough to the logo, right? So if I make it bold, if I reduce the kerning, that's good enough. No, it isn't. So, if you have ever been in a VMware marketing or brand training, it's 5 minutes of these are the colors you're allowed to use, and 55 minutes of do not touch the logo. VMware, this is one of the earliest logos, yeah. Also not cool, right? No all uppercase. I mean, actually in all uppercase maybe potentially in some circumstances, but not. But now the most important one. VMware, who thinks, oh, this looks good to me? Oh yeah, a couple. No, this is the one point where you want to be shy, do not raise your hand. So this VMware is probably because of our ticker symbol, which is VMW, right? Enjoy it while it lasts. But maybe, at some point in history, right, it really, maybe was VMware? So this is a mission letter. I point you to Exhibit A here. This was exhibited at VMworld 2018 in Las Vegas and Barcelona, and this is the original mission statement from VMware, from 98, 99 or something like that. Doesn't seem like a typo, right, if it repeated 3 times? So, I did some research. VMware, this is the archive.org, the Wayback Machine, donate if you can, great resource. This is a snapshot from the 25th of January, 1999. VMware, capital W, capital EW down there. A coincidence? The next snapshot, a couple of days later, VMware, how we love, like it, and should write it with a lowercase w. So this is only a couple of days later, but snapshots are just snapshots. It doesn't really tell us when these pages were created, so I followed down the rabbit hole a little bit more. So we know for this period in time, something happened in between that, or maybe before that. So, the who is of VMware.com is 30th of January 1998. I looked up the statement of incorporation for VMware where it said that on 10th of February 1998 it was VMware, and it says, I then contacted the support, government of Delaware, right? And they said there is no name change on file. The story thickens, right? So, that's how I spend my time instead of solving your performance cases. So, I risked going bankrupt here, right? Because this is the Excel sheet that you get when you request something. So I actually ordered 24-hour service and I had no idea how much it was going to cost me, right? Didn't end up bankrupting me, but I got it after 3 days. 24-hour service, charged me after 3 days. Didn't hear anything for about a month or two, right? I mean, figure government service. So what do? Well, you ask the founders. Well, how do you ask a couple of millionaires about the capitalization of VMware? You look for the easy targets, the one that have their email address public, which is professors and universities. Mendel here did not have his email public, just his assistant, and I did not get through. Luckily, I got Ed's direct email address, and he told me he has no idea, but it's an interesting question, and he referred me to the first non-VMware employee, which was Reza. And Reza actually got back to me immediately. And he said the change had to do because of a concern about trademark registration, long story, and he didn't elaborate, which is his right? I mean, that's good enough. Now, I checked the trademarks. You thought we were done, yeah? And someone in another session actually told me, well, VMware isn't capitalized correctly in the search bar there. It's all right. Anyway, so VMware in April 7, VMware low uppercase W, and later, when we registered Linuxware, it was VMware with a lowercase w. By the way, we gave up Linuxware. If you want it, it's yours, free for grabs. Now, I got a letter 2 months later, and that finally showed the original corporation, and it was VMware with a capital W in the very beginning. So, why did we just do this? Well, because, yes, it very briefly used to be VMware with a capital W. There is your free out of jail card, jail out of free card, you know what I mean. But it has been VMware for 22 years, right? And many people in VMware, right, get really eye twitches when they see it capitalized correctly. I think the energy of all the VMware employees twitching their eyes could power a small country by now. But yes, that is this. I have some backup slides as well. I just saw 2 people leave like 20 seconds ago. I'm sorry. I could have rushed it a little bit. See, I'm already taking over from Mark. No, sorry, Mark, if this is recorded, I'm not trying to take over for you. He's irreplaceable. Oh. All right, time for some water. VHT. So, virtual hyperthreading. In the top right corner, that's supposed to be an apple pie. Now, I looked for a stock photo while I was flying over here, and I only had paint.net on my laptop, and it took me like 3 hours to do. So I'd like some appreciation, even though. Thank you very much. Yeah, half-hearted, but I take it. So, we have to talk about hyperthreading and latency sensitivity before we explain VHT. Hyperthreading, I mean, most people should be aware, simultaneous multithreading, as it is called by everyone else except Intel. Basically works on the premise that you can run multiple instructions while some other parts of the CPU are not doing something, right? For example, if a CPU is waiting on memory, if there's a stall, load, store, you can run something else if you provide a second funnel, like a little bit of extra logic, into the CPU, right? For that, some of the parts, you need more parts, right? But a lot of it is partitioned and shared, meaning the 2 executing contexts actually share resources on the core. Wherever there are shared resources, what does that mean? The possibility for contention, right? So, the cost of SMT is about 5% of a die, and it gives you 10 to 35%, right? Even more if you highly optimize for it, if you exactly know what your threads are doing, and if you affinitize them, and if you eliminate variance, right? But on average, 10 to 35%, maybe 0 for some workloads. It's highly unlikely that hyperthreading in itself will reduce your performance, right? And here I say performance, I actually should have said throughput or capacity, right? Because performance could be misinterpreted as speed or latency. I purely mean throughput and performance and capacity when I say performance. ESXi cannot tell how much benefit hyperthreading is for any given workload, right? So we just assume a flat 25%, like texting. But so the reason is that we can't really tell what an application is doing because we'd have to look at CPU monitor counters, right? And that would be hugely expensive to figure out what's going on. So we just say, you know what, whenever 2 threads run together, the core is 25% more effective. Now, as I said before, right, most of the benefit is if one thread is waiting on memory and doing something, and the other can use any other execution context or port on the CPU and do something there, right? It's very hard to predict what's going to happen if you just run 2 threads of any application, right? Anyway, so a few common misconceptions are, what actually happens when I turn on HT? Do I turn it on the host and the ESXi host? What happens to my workloads and how will my performance change? So if I enable hyperthreading, do I get just two same size logical CPUs that have the same performance? Basically, I double my performance. Will I get a large logical CPU that has the same performance as the core, and then I get a tiny, tinsy little bit 25% logical CPU? Or do I get two logical CPUs that in sum would be larger than a core, but wherever I run my thread, it would be slower than it would on the original core? None of it. Take a picture now. None of it. What it actually looks like is closer to this. Everyone knows how these work, huh? Funny. So when something is utilized, right, but you have its individual throughput reduction, aggregated throughput increase. So individually you get less work done per thread, but the sum of these two threads is more than one individual thread could by its own on itself, right? So hyperthreading makes things slower. Individually, it allows you to get more through together, right, in the aggregate. I actually have one of these for work. And I don't mean that I wear that at work to get through work, although that's not too far off on some days. I actually have it to do like in Zoom sessions because I think it's funny, but I didn't bring it because this isn't Las Vegas and I'm not Carrot Top. Plus I didn't want it to get damaged in my luggage. Anyway, so there's a couple of the questions that I get really, really often is what is the difference between utilization, CPU usage, core utilization? How does that work? I have no idea how they interact. And those are very good questions, and I can provide a partial answer for utilization and usage here. By the way, we do something else. In the past, we've done the performance best practices, which is not running this year, sadly, and we have this performance workshop, which used to be a workshop, but now it's just a big presentation. And we have these recordings, and we talk about many different things, right? In this one here, we talk about usage and utilization. This is the VMware link shortener, and it will get you to the recording of that session, I think, last year or the year before. Anyway, that being said, nomenclature at VMware for ESXi, a pCPU is always the top level unit of where something runs. You might think pCPU, that sounds like physical CPU. That's exactly what it stands for, but the nomenclature is vCPU or world, which is our thread, runs on pCPUs. If you don't have cores, the core is the pCPU. If you have hyperthreading, and if you don't have hyperthreading, you have a core, and on top of that you have two pCPUs. Now, these have metrics, utilization and usage, and then there's core utilization for the core. I also brought in an imaginary figure here, which is core usage, which we don't really have. It's to mix the concept and to just explain what I mean by throughput. Now, this looks a little bit busy at first, right? But what I'm trying to show you is that core utilization is only idle, basically, when both threads are idle at the same time. If either pCPU 0 or 1 is executing something, right, core utilization is also utilized, right? And so basically, idle is the halt instruction or the mwait instruction whenever we run our idle threads on a CPU. Anything else is any other instruction that is currently being executed, whatever that is, right? It's just idle, running, two states. Usage, on the other hand, is a qualitative metric. It shows you how fast something is running. It takes into account frequency, the cost of interrupts, the overhead of hyperthreading, and so on. So what you see here, when two threads actually run at the same time, individually, the worlds, right, get thinner, but the core utilization actually gets bigger. Well, that's wrong. Okay, anyway. So basically, the core utilization gets thicker whenever there's two together, right? Individual cost, aggregated benefit. A little bit like socialism. Anyway, so we have hyperthreading, and what does ESXi do with that? Well, ESXi tries not to use hyperthreading at all, like any other operating system, because of the individual throughput reduction, right? ESXi tries its best not to schedule two vCPUs on the same cores until it has to. Why should it have to? Well, if someone sets affinities the wrong way, right? If someone sets, not if someone sets limits, but if there is, for example, ready time, right? If there's any contention going on, then ESXi might think, you know what, I could wait on this core to be available by itself, but probably I should run them together because the impact will be less. So there is what's called a goodness calculation going back on in the background, and basically ESXi accesses that very often, very fast to give you the best results. That's why what I meant with that enabling or using hyperthreading or not having hyperthreading is usually not a performance impact, because hyperthreading is really only used at the far end of host utilization. So if you run below 60% host utilization, chances are you're using hyperthreading maybe 1% of the time, right? So also, host usage is capped at 100%, which doesn't include hyperthreading. I hope you did a picture of the link that was before that talked about that, because we explain it there in detail. Now, for the guest, as far as the guest is concerned, Every vCPU that is presented to the guest operating system is a full core. We do not present any we did not present any SMT information to the guest operating system ever. You could schedule 2 vCPUs on the same core and the guest OS wouldn't know. All it would maybe notice it that all of a sudden it runs slower, right? It could not, it's fully transparent to it, right? Also, it's kind of hard to change SMT information on the floor. Imagine you schedule something around, right, and you have to update hyperthreading like 1,000 times per second. The guest OS probably wouldn't be too happy about that. So, with that being said, let's go into latency sensitivity. Who here has used latency sensitivity? Hi. That's a couple of people. Good. I'm actually happy it's not more. Why? Because some people think, wow, there's a button that'll make things faster. Let me press it. So, if something has only benefits and no costs, it would be the default, okay? So if there is an option to do something, there is some cost associated with that, and I'm trying to go through this right here. So what this setting actually sets is it sets CPU's latency sensitivity equals high. That's the VMX setting that actually happens. And it sets different things for the CPU, for memory, and for network. It's a big profile. And I'm going to go through the settings that happen under the hood. You don't have to set these, right? This is the one thing that gets set automatically if you change in the UI, or that you can configure via API, or however you want to do it. But what happens behind the scenes is what I'm trying to introduce in the next 3 slides. It sets a direct and exclusive vCPU to PCPU affinity. That is not the schedule affinity that you see in the UI here, right? It is actually a per vCPU affinity. This affinity, the regular one, is really just setting vCPUs to a group of pCPUs. Basically, you can define a range or individual pCPUs, and affinity only means you can only run there. It does not mean that nothing else can run there, right? What latency sensitivity does, it actually sets a per vCPU to PCPU affinity. This vCPU is only allowed to run this PCPU, so you're avoiding all of this rescheduling across the pCPUs of the host. It also sets exclusive affinity. Now, this is the part that says, hey, whatever runs there is the only thing that's allowed to run there. Don't mix up affinity with exclusivity. Affinity just means you have to run there. Exclusivity means nothing else is allowed to run there. And in the past, right, or the default for high, still to this date, is that if the vCPU has exclusive affinity on the core, nothing can run on the hypertwin, meaning on the other PCPU of the same core. For memory, right, so this is memstats running on an ESXi host. It just runs through the grep Z there to get the relevant lines. And you can see that mem size, allocated, consumed, mapped, and touched, besides touched, is all the same, right? So here all the memory is pre-allocated. In the past, touched, or the active memory metric, time for some water, used to be 100% as well. But then you all got CPU high usage alarms, and you didn't want to turn out the usage alarms, so we reduced it to 75%. So we wouldn't have to hear about it anymore. But really, the alarm is useless. I mean, not useless, but it really, I haven't seen a real use case for this alarm. It should never have been introduced. Activity is there to tell you the entitlement or help you in calculating the entitlement and make some guesses of what's happening in the OS. It was never there to show you what the guest operating system is using. Anyway, reduce it to 75% and all of a sudden the crying stopped. So what else does it do? Well, scat memory pre-alloc pinned main memory. That is the actual setting that happens. And this is the same setting that happens when you enable 1 GB pages, fault tolerance, path-through, and vGPU. Right? If you do any of that, you also see that your guest OS memory usage, so active and touched, is locked at 75%, which is the same number that we set active to when we boot a VM. Because when we boot a VM, it's fairly active on its own, but we also don't want it to be under-prioritized in the boot process when it might not be doing anything. So we set it to 75 in the beginning. So for anything where you see this, guest OS and active will be locked to 75%. Since 7.0 update 1, I think. Before that, 100%. Now, it disables ballooning, transparent page sharing for real, zip, swap. It enforces that you reserve it in full, and it disables memory sampling, right? Memory sampling, by the way, is active, touched, since we fully force that. You cannot move that memory. Once it's up, it's there, it's yours, no second or hidden page faults, nothing. For network, we basically remove disable LRO. It's the same as if you would disable LRO in the guest operating system itself. You can only do it outside of the guest on a per host basis. It disables coalescing. So coalescing is if So because when you virtualize something, right, the largest cost and overhead nowadays is I/O, because you have to go through 2 I/O stacks at the same time, meaning you double the cost for I/O. So what most defaults are is heavily coalescing that, meaning that if packets come in, you don't interrupt on the second packet, you interrupt on the 20th packet, right? So you introduce a little bit of latency, but you get efficiency. You don't have as much CPU utilization. Now this disables that. Some people say, well, if I have enough compute for any of my latency sensitive-ish workloads where I don't want to enable that profile, I just disable coalescing. And yeah, that's a good tuning opportunity if you want to do that, but I think you shouldn't just blanketly do that across all your VMs. There's some other costs involved there. Also, it disables dynamic queuing. So for VMs that do not really do a lot of I/O, ESXi sometimes shares the hardware queues for the NICs, for the net queues. And if you do latency sensitivity equals high, you get your own private VIP queue to the NIC. Now, if you don't want the network stuff, but you like the memory and the CPU stuff, you can disable the network stuff on a host basis, not on a per VM basis, sadly. All right, so with latency sensitivity equals high, it is as close as you can get for cutting out a piece of hardware out of a virtual machine. With 7.0 update 3, we made further improvements for RAN workloads, right? So telco workloads, and the jitter times are on par with bare metal. Again, it's as close as you can get to cutting something out of a machine and giving it to a VM. And the session there talks about that in a little bit more detail. I think that was from 3 years ago. Now, the undelivered demand catalog is usually deleted after 3 years, so I uploaded it to YouTube, but don't tell anyone. Someone uploaded it to YouTube. Fuck. The recording is already out. We're using the Monday one. Okay, so now when you look at latency sensitivity in that release, oh no, I can say it, 8.0. Now you see actually latency sensitivity normal, and you see 4 cores, 1 threads per core, because you now can select high with hyperthreading. And what that will do is actually present the underlying SMT information to the guest. Now, so let's configure this, right? If we set it, it tells you high latency sensitivity requires you to set 100% CPU and memory reservation for this VM. Great, right? This is a 4 vCPU VM, 2.1 gigahertz CPU on the host. That means 8.84, right? What that actually does underneath is it is just latency sensitivity high, the one that we know and love already, and it's setting num SMT to 2. Why is it configurable with a number? Why not just true or false? Well, because you can have more than 2 threads per core in principle, right? Power architecture already does that. Maybe x86 will at some point in the future too, so maybe that will be set to 4 or 6 or 8 or 20 or whatever number. So we'd like to be prepared for that. So you only have to remember one setting, or I have to remember one setting. So reserve all guest memory, that's easy. This is the checkbox for that, reserve all guest memory locked. Locked is not a good name. Locked, some people think it's pinned or it's pre-allocated. It's not. Locked just means it's locked to the actual assigned memory. Whenever you change the assigned memory, the reservation will grow itself. Funny trivia, if we have time, the only setting that is not recognized by VMX, it's only recognized by host D, because it only says, long story. Anyway, so this really just ensures that your VM has the same amount of memory reserved than you have assigned, and it's easier to set that checkbox than to type it out, right? So we set the CPU reservation 8.4 gigahertz, and we pound the VM. What's that in the top there? Insufficient capacity on each physical CPU. Well, that's underwhelming. Why does it happen? Well, we double check. The frequency here that we check is 2.1 gigahertz. We look here for processor speed because sometimes that's a couple of megahertz off despite there being despite it being rounded to some extent. What you see above there in the model, that's just the brand string. The brand string is a part of CPU ID that is being passed through little string characters, right? If it says 2.1 gigahertz, that doesn't mean it runs at 2.1 gigahertz. It could be running at 2095 megahertz, right? Just a string. So we measure that. Now, what did I just do? I reduced my reservation by half. Because 100% CPU reservation doesn't mean 100% vCPUs. It means 100% of the cores. If I have 4 vCPUs with hyperthreading enabled, how many cores do I need? 2, right? Who thinks this could have been improved in the UI a little bit? Thank you very much. You make my case. I should have taken a picture here. Why do I always say screenshot when I mean picture? Oh. I should get out more. All right, let's look at ESX Top. Who here uses ESX Top? Who here loves ESX Top? My people, great. Oh, I shouldn't have done that. Very good. I love ESX-Top. What we're doing here is we're looking at the single VM. We limited the display to the VM itself. We expanded it, so now you see the individual worlds, like threads, in that VM. And if you see the used and run here, this VM is running 100% of the time, meaning it is scheduled 100% of the time. It is not being descheduled so that we can run idle threads on the PCPUs. So that means exclusive affinity should be working, but you can double check that. In ESX-Top, you can enable the summary fields, and in that you see the CPU it's running on and whether exclusive affinity is set to yes or no. Exclusive affinity, I think, has been available since 6.7, the field. And what else do you see here? Actually, you know what, ignore that, the reveal is already there. It is sequential, right? The vCPU is on 36 and 37. And 38 and 39. There could be a gap in between those two, but the important part is that the vCPUs are next to each other because we want hyperthreading, right? So that is how it looks like. Now, in the guest, before you do that, and here you already see a little bit of a preview on the CPU topology enhancements, you see 4 vCPUs, 4 cores per socket, and 1 thread per core. And what do you see inside of the guest OS? The matching figures, right? Now, with it enabled, you all of a sudden see 2 threads per core. Yay! Hyperthreading is passed through, and you see 2 threads per core on CPU topology. But you still see 4 cores per socket, even though it says 2 cores per socket. Why? Well, because we didn't want to rename cores per socket to vCPUs per socket, but it should have been in the beginning, but you know, it's historically grown. So you kind of have to remember that there is going to be a difference between these two. So yeah, great, that's VHT. So who of you will be using this? Probably not often and not many. This is originally a telco feature. So basically for highly optimized workloads, right? So the reason why you wouldn't be really using this, even if someone says, hey, my workload makes benefits of hyperthreading, that doesn't mean that it needs to know that it runs hyperthreaded. It just means that the threads in itself, when they run on the same core, don't get into each other way too often, right? So they're not like polluting each other's caches, for example. They're not running something completely else. They're running the same working set. So if you want to use hyperthreading, you increase the density of your hosts. You start ignoring CPU usage, which is capped at 100%, meaning nominal frequency, and you look at host utilization in the real-time stats, and you add these to VROPs. Because now, if you increase density, ESXi will utilize hyperthreading for you, right? Now, that being said, it is still a great feature, right? If you already have latency-sensitive high workloads, and they don't mind hyperthreading, you might set this to save a little bit of resources, and you don't have to do that exclusive affinity manual tuning with like sequential vCPU affinity. So if anyone here in telco? No? One? Okay, yeah, but you probably know some workloads that you had to manually. It was a big mess, and now it works better. So, no, more topology. So this is going to be more interesting for everyone here that isn't in telco, but this is an advanced show, so we'll cover the advanced features. Now, whenever you create a VM, what used to be here? Cores per socket, right? Here you said cores per socket, right? Now you set CPU topology, assigned at power on. Great, right? You have a full UI for that available. Now if you go to VM options, CPU topology, all the settings that you want in one place makes it easier. You don't have to manually configure anything anymore. Now, the assigned at power on now means cores per socket is assigned at power on. You don't have to bother anymore. You don't have to figure out what you want to do. But if you want to change something, everything is in one place. What you also see here is the device assignment, right? You can now set the virtual devices to individual vNUMA nodes. That is new. Why does it matter? Actually, let me talk about topology a little bit more. So in the topology here is now in the lists the vCPUs and threads per core. We saw that earlier at VHT. In the new UI, whoever didn't enable the preview in 7.0, that's the new stuff. It's there now by default. You can't change it back. But you can move these little thingies around, and I think topology belongs on the top, so I always move it to the very row of all my VMs, because that's where it belongs. Okay, let's talk about why we actually do this in caches and terminology to just come to be on the same page for all of the following stuff. If you look at the CPU and the layup and what actually consists of it and why these certain parts matter, or the high-level parts, is you have cores, you have caches that are exclusive to these cores, and you have shared caches, and then you have memory, right? IMC integrated memory controller goes to DRAM, QPI, Intel terminology, quick path interconnect goes to another socket. So if you stay within a core, right, L1, L2 cache, they're tiny, but they're fast, right? And they're larger. That makes them, I mean, they're somewhat larger and fast. Plus, at the size of a CPU, light travels like this much in a nanosecond in a vacuum. So, and then these are highly integrated, right? So it actually matters how fast light is, and you can't make light faster, I heard. Last I checked. So L2, also fast, right? But a little bit larger. Now this is why we have VHT, because some people actually optimize their workloads for that cache locality in the core caches, right? It's also why we had L1TF. Who remembers that? Yeah. I lost a lot of sleep over that. Anyway, are there people from Intel here? No, I'm not going to ask questions. All right, so L3 cache. That is the cache that is shared among all of the cores. So if two workloads run on two different cores and they happen to hit the same cache line, they share it. No more going to memory, because memory is slow, even if, well, slower, right? Even if it's completely local memory. And then obviously we have DRAM, right, which is slower, and depending on the setup, the ranking, the CPU, the type of memory you have, and so on. So it's really hard to give you a figure on how fast memory actually is. Anyway, the terminology. We all know DIMMs, right? DIMMs are the little things that you put in, the things that you reseat when support tells you to reseat them because that might fix the issue, despite it never fixing the issue. Whoa, don't laugh. I'm in support, that's offensive. But I think I'm actually going to do that for one of my next customers. Reseat the memory, maybe that works. Then there are sockets. Sockets or packages is the things that you can actually touch, remove, put in, throw around, return to the vendor. And if you have a problem like a PSOT that always happens on the same pCPU, you change around the sockets, right? To see whether it follows the change of the package. Now, many people call that a NUMA node. And to be fair, in the very, very beginning, maybe they were right, but not really, right? AMD Opteron in the very beginning had 2 NUMA nodes per socket already, right? So we can all agree that a socket is not necessarily a NUMA node. Just because it very often is, doesn't mean it is a NUMA node, right? Intel introduced cluster and die in Haswell. So basically you have multiple LLCs per socket as well. So the reason is at certain CPU sizes, the little caches are assigned per core in a ring, and if you have long enough, you split them up in 2, get better latency and whatnot. It's called, in recent releases, or since Skylake I think, it's subNUMA clustering. It's enabled by default on HPE systems. It's not enabled by default on Dell systems. I think I prefer the Dell way, and not because I'm biased, because that's over now, isn't it? But really, subNUMA clustering gives you latency benefits if you have optimized workloads for it, and if you don't overcommit, and if there is not too much churn, right? I prefer to keep scheduling simple. The less NUMA domains you have, the easier it is to place workloads and fit them appropriately. Now, Zen does whatever it wants across the releases, right? It has multiple LLCs per NUMA node, multiple, I'm not gonna go there, right? But it's complicated. So what I'm trying to say here is a socket is not a NUMA node, a socket is not a last level cache domain. They're different or orthogonal topologies that all have to be evaluated at the same time. So let me talk through some examples on what happens when you power on a VM for the first time on ESXi. Do you have less vCPUs than cores in a physical NUMA node? Great. We create a PPD, we call that a physical proximity domain or NUMA client. That is the atomic unit of ESXi to schedule vCPUs between NUMA nodes. If we want to move vCPUs, if one NUMA node becomes too busy with too many VMs or NUMA clients, we move a NUMA client and the memory follows over, right? Like a little string attached to it, the memory is pulled beneath it. We cannot schedule individual vCPUs to another PCPU on a different NUMA node. All the vCPU moves to their home node of that PPD. So it's a scheduling construct. To abstract that, we introduced a virtual proximity domain, and that is what we present to the guest operating system. The reason why we do that, right, is because it needs to see something, but we need a layer in between so we can change the scheduling construct, but we don't have to change what the guest is being presented with, right? If you have more vCPUs than cores in a NUMA node, again, we create 2 PPDs, right, because now the vCPUs don't fit into the cores anymore, so we have to make it wide, and we also create 2 VPDs. And again, the VPDs do not change. And the reason is because we don't want the guest operating system on reboot to think, oh, I'm running on a completely new, different infrastructure topology hardware. The reason is old. vNUMA is old, 5.0, 10 years. The reason we decided to do it that way was specifically because one application decided to save the NUMA topology when it was installed, not when it is running. Oracle DB. I'm pretty sure it's fixed by now, right? It is definitely fixed. So we could, in theory, wait, did I go forward? So in theory, we could probably remove that, and you can do it per power on. If you want to recalculate vNUMA on every power on, if you just Google for vNUMA on our docs.vmware.com site, it is autoscale auto size true, auto size once false. So basically in every power on, not guest res, reboot, power cycle, vNUMA is calculated based depending on which host it is on, especially if you're running in a very heterogeneous environment or if you're changing server hardware. That is beneficial. Most modern operating system and applications benefit from that. They do not suffer, but if something breaks, don't call me. All right, so what happens if you have more vCPUs in a core, but less vCPUs than pCPUs in NUMA nodes, or the same vCPUs? There's an equal sign missing. I'm gonna get, my math teacher's gonna, no, never mind. So what you do here is, if you set NUMA prefer HT true, and the setting has a little bit of a history, and some people think, do you force hyperthreading? Not really. It really is just defining the boundary, right? If you have prefer HT true, the PPD will be bound by the threads, the pCPUs, if you have hyperthreading enabled, instead of the cores. That doesn't mean you will use hyperthreading, because hyperthreading still is under the CPU scheduler, not the NUMA scheduler. If you only use 4 vCPUs out of your 20, then you don't use hyperthreading, right? Because they're still going to be scheduled on individual cores. If you run more vCPUs than you have cores at 100%, yes, then you will start to use hyperthreading, and prefer HT does that. But it's not a scheduling option, it's a sizing option. And a better name for it would probably be count threads instead of cores when sizing PPDs, but that's a mouthful, so I think it's prefer HT. All right, hotET. Who knows what happens with vNUMA and hotET? Yeah, exactly. What happens if you have a white VM and you enable vCPU hotET and you create and you power on the VM? Now you have in principle white VM, but not really. So we still create 2 PPDs because we schedule them separately, right? But the guest OS has no idea where the memory is and where the vCPU is, right? So in theory, if it was really, really lucky, right, it would be all memory 100% local. Not that you could tell from inside the guest operating system. It's a matter of information, right? Now, with 8.0, there's this parameter here, NUMA.allow hotET equals true. Guess what that does? So, now if you have vCPU hot enabled and you set that parameter, which is not available in the UI, you have to set that via VMX. And now, if you have 2 PPDs, you have 2 VPDs, and now you can hotET vCPUs. Now, does that come at a cost? Is there maybe something that we should talk about? Yes, it is. Now, Mark isn't here, right? And he has some thoughts on hotET, which is so I'm going to call him here. Ding, 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 ding. Yeah, Mark, yeah, I'm right here. Someone says here they're using hotET for every single VM. All right, language Mark. So basically what he's saying is that hotET is not really a technology problem, it's an organizational problem. hotET, if you set it, what do you do when you want to remove those vCPUs again? Use the CPU hot remove function that we have in the API that does not work? No, because it doesn't work. It was planned to work, but that was like 10 years ago and not really touched. You cannot remove hot edit CPUs live. There's a little bit of reason behind that because some of it is guest initiated and then you have to react to that. You can offline CPUs in Linux, you can core park them in Windows, right? So in theory you can get rid of them and barely schedule them anymore, but you can't really remove them. Memory hot, it works just fine, right? So it's unlikely that it will solve your issue, right? You should not have this enabled by default. Also, if you have a server, bare metal, right? It has 4 sockets, 2 of them are populated. Can you add a single core to another NUMA node? No, you cannot. You have to put another socket. Guess what we have to do here? If you decide on a topology, you now have to add an additional socket if you want to do NUMA hotET, because that is what the guest operating system expects. Even if you would add 2 vCPUs, right? You cannot change a NUMA construct under the operating system. Bad things happen, right? Maybe at some point in the future, the OS, we can do more dynamic scaling, but right now, don't go and configure this just because it's possible, right? If you really, really need it, especially if you have tiny and small VMs that will not grow outside of a NUMA boundary, feel free to use hotET if you have orchestration in place that can limit it to the maximum amount of vCPU size. Do that, but don't just splatter it anywhere, right? Just because it's possible doesn't mean you should. But again, it's possible now. Hey! Okay, so virtual devices. This is what happens when you run ls topo on Linux. And this is where the devices are. On the top you see the NUMA nodes with the memory and the CPUs a little bit shorter, and in the very bottom you see the devices, not assigned to a NUMA node. It's like as if there is NUMA plus a north bridge and a south bridge for all the CPU devices. Now, for the most part on bare metal, right, you have an I/O port on a socket, and some devices are on one NUMA node, and other devices, PCI routes, are on another NUMA node. Not so in virtual hardware. They're not NUMA aware. So, but with 8.0, right, we could set that. Hey, wasn't there a setting? Yeah, it turns out that you can't use the legacy BIOS because we basically created a whole new mainboard for that function. It's not the old mainboard, it's a new one. So you cannot use that with the BIOS. So hey, can we just change it from BIOS to EFI? Has anyone ever tried to change it from BIOS to EFI? What happened? The predictable, exactly what we said here happened. You can't pound the VM. Well, in theory, you could predict it. You could fix that manually. But if you want to install your VMs with EFI, it's 2022. EFI should be the default for most new VMs. Despite it not necessarily be the default for most guest operating systems. Let me preface that, right? So when you create a guest operating system, the default sometimes defaults to BIOS. Maybe you want to set that to EFI going forward. Now, but this is what it looks like. We have a host bridge down here for the new VM that I created with EVI, and this is now available. I can set the devices to the individual NUMA nodes. But I have to actually manually select the AutoCoresPerSocket size and the NUMA node size to be allowed to set the devices. Why is that? Well, because we want to make sure that you really know what you're doing and that you purposefully set these devices. You could copy what ESXi did for you. You pound the VM, you note down what it did, the optimal configuration for locality, and then you can configure it. Now you can actually set the SCSI controllers individually to NUMA node 0 and NUMA node 1. So this is the NUMA node that the guest sees, right? So you can even be more precise here. Oh, now that you run it, right? You now see the host bridges inside the guest associated to NUMA nodes. So you run LSTopo and you see where these are. If you have workloads that are very, very sensitive on that kind of stuff, that will be pretty cool. And even after that, you could run it with specific NUMA client affinities. Now, some people might know NUMA.node affinity, which is setting the node affinity for the whole VM to a specific NUMA node. Since 7.0 update 2, you have per virtual NUMA node affinities. So you can set one NUMA node over here and another NUMA node over here, or over there, however you want, right? Now, don't do that for don't do that for existing VMs, right? Ripping out a PCI device and putting it somewhere else is not a gentle process. So chances are that's going to break, especially if you do that with a NIC. What happens if a NIC gets removed and you put in a new NIC? It's not your old NIC, right? So the IP address and everything is gone. So if you do that on a live system, you better make sure that your KVM was working beforehand. How did I find that out? I guess. Topology, AutoCoresPerSocket. So you've already seen it here, right? But now we're going to really talk about it. Who has ever Googled that? Oh, come on, be honest. I Googled that myself. Yes, at least a couple of people, right? So there's a couple of articles on how to handle AutoCoresPerSocket. One is in 2013, one is in 2017. You find so many resources that say different things, and they're all right in their own way. Now, isn't that neat? Before we talk about AutoCoresPerSocket, actually, this is a fling that the Mark released, and this will calculate pretty much exactly the same way that AutoCoresPerSocket does. It doesn't configure it for you, but it calculates the best CoresPerSocket size and the best vNUMA size in case you have changed that. It also takes into account, does it take into account memory? Oh, I'm not sure yet. But this is if you can't upgrade to 8, and to be honest, to upgrades, I mean, who here upgrades to 8.0 at G88 on all their production? I do, but I don't have production. So all my lab is already running on 8.0. Ahead of the curve. But in case you're not quite on 8.0, this is still something that you want to utilize for your important VMs to size them appropriately. If you don't really know what you want to do, this is doing all the hard work for you and it gives you a report. Now, why the different recommendations? The reason is, well, there's two types of recommendations. One is, you're unlikely to break anything if you do that, and the other one is if you have the operational capacity and you know what you're doing and you want to go through the pain of doing that all manually or thinking about it, then you could optimize it further, right? The leave it at 1 is the you won't break anything if you don't touch it. The optimize it to match the hardware is the yes, that's the better configuration for the most part, but it might have other side effects and you have to know what you're doing. And when we say match hardware, we don't mean, hey, you have to set it to 2 cores per socket per node, right? So when you have a 2-socket host, it doesn't mean you have to set it to 2 sockets for the VM as well. So 4 vCPUs, 2 sockets. It means you have to size it to the boundary of the underlying NUMA node, where the vCPUs actually are. So if you have a 4 vCPU VM, these 4 vCPUs fit into a single socket. So you give it 4 vCPUs per socket. Now, this is all assuming, right, that perfect information delivers perfect results. And we all know that not to be true. right? The assumption here is that the guest operating knows what it's doing. The assumption is that the application knows what it's doing, and the assumption is that it's perfectly configured according to what is the underlying topology. That doesn't hold true. But we can hope, right, that at some point in the future, more optimizations are being made and that the perfect topology information will result in perfect scheduling, right? And that's why we're doing this. We want to present the most accurate topology so that the guest and application can take the most accurate decisions. A little bit more history, less capitalization. I started somewhere there in 2009, just before ESX4 released, so just in time to support it, 1 week too late to get the actual launch t-shirt, which I'm still very mad about. But that was also the first release we introduced CPU IDs CoreSperSocket. Only for licensing. That was the only reason. Some dude couldn't power on his Windows XP VM, says, well, I have 4 vCPUs here, it only supports 2 sockets, you're giving me 4 sockets with 1 vCPU each, give me something so I can change it, so we did. No one thought about caches and latencies. I mean, some people probably did, but I mean, literally it was for licensing. That was the intention. So then, the next release, we introduced it in the UI, and it was actually supported. But at that time, the maximum number of vCPUs was 8. It's been a long time. In 5.0, we introduced vNUMA, and we increased the per VM max size to 32, and we also set the minimum amount for vNUMA node to be 9 vCPUs. So if you ever create a VM with 8 vCPUs, even if you have a 2-core NUMA node, the VM will not be wide, right? A VM will not get auto size, it will only ever see 1 node if it stays below 9 vCPUs. If you create it with 9 vCPUs, you will create 3 NUMA nodes, by the way. So, the reason is that we didn't want any regression. I mean, it's behind a hardware switch as well, but in any case. At that time, we made a decision. And I'm being ominous because it wasn't the best decision. Ominous? No, that's not the right word. You know what I mean. So we set CPU cores per socket to the same as max per virtual node. Meaning we decided that, hey, if someone wants to set cores per socket, they probably know what they're doing. We're going to have them configure vNUMA automatically as well. Because, right, full control over the system. Turns out that wasn't the best decision to be ever made. So again, as I said before, right, what we want perfectly aligned hardware. We want CPD to be the same as VPD, and the CPD, right, it doesn't, so the cores per socket, CPS, doesn't really affect ESXi scheduling, but it affects potentially how the applications and the guest operating system do things, right? The NUMA topology doesn't affect our scheduling, but it affects how the guest is doing things. The PPD is what we actually schedule, the NUMA client, as I outlined before. And in case, right, if we, well, I didn't delete that. Even if it's wide, right, we want this all to be perfectly aligned because in theory that gives us the right information. Now, if you didn't set core per socket before 6.5, it was left at 1, but the VPD was sized automatically. If you made CPD too small, you over-fragmented the vNUMA nodes. If you made it too large, you made a wide VM even though it wasn't wide, right? So chances to break things. In 6.5, all we did is we cut that line. Basically, if you want to break something, you break only one thing at a time. So now, if you misconfigure CPS by accident or because you change hardware, right, it doesn't also mess up the NUMA topology. Now, when we did that, does anyone remember 6.5, the release when you had custom NUMA configuration and UV motion, and that P started all your hosts? Yeah, that's not going to happen this release. Pinky promise. So in 8.0, all of that is done automatically, right? That is the highlight here, right? You don't have to care about that anymore. You don't have to set cores per socket. All of that is being done automatically for you for new VMs created with virtual hardware version 20. Now, known issues. So vTopology doesn't yet work with OVF, so it doesn't work with content library. And if you're using VHT, there is a chance that some of that will be affinitized to the first core. Now, why does that matter? So, let me actually track back a little bit. Some people think that ESXi only runs on pCPU 0 or core 0. That is misleading, to say the least. In the past, ESX Classic, the console operating system, did run a little bit on pCPU 0. It was actually more of an affinity. What is still the case, though, is there's some hard-scheduled interrupts that still arrive on core 0 that is not arriving anywhere else. So if you have any latency-sensitive workload, you have more jitter on that first core. And that might happen here, but that is already fixed, comes with a patch. All right, so most workloads will be optimally configured. Again, most workloads. What comes when I say most? Well, there will be a few regressions, right? And there will be regressions probably for workloads that you test certain things for performance. But the regressions are because the workloads themselves aren't optimized. They get the good information, but they don't do good things. And sometimes you need to give people sometimes you could give people white lies to get better results. Like when someone tells me the deadline for the slides is 1 week before the actual event, because they know that I'm going to deliver them 1 second before the deadline. And that is sometimes beneficial, right? Here, this is an example from the Topology blog post that is going to come out at GA or a little bit later on NetPerf and what it does. This is a Windows Performance Toolkit collected ETL. This is displayed using the Media Experience Analyzer, MXA, from Microsoft. Great tool. It makes it a little bit easier to see where the OS is scheduling things. And the first one is 1 core per socket. The other one is 4 cores per socket. So vTopology disabled on the left, enabled on the right. And what you see is that the NetPerf thread is running on the same core as the IRS from the driver. And because of that locality, you have a benefit there. Now, without it, NetPerf just thinks it can run anywhere because migrating across or within a socket is cheaper than across sockets, right? So it thinks it can run anywhere. And what does that lead us to? No locality anymore. Now, this happens on bare metal too, right? This is not virtual. This is something that happens everywhere. The problem is on virtual, it's a little bit more expensive. So this is where you notice things, right? In the past, you have solved this with task affinities in the OS itself. But you do that on bare metal as you do it on virtual. Now, the full review will be at vTopo, and the links will be at the last slide as well. You can take a screenshot then. But there will be a full review with the different apps and different reasons where it might regress a little bit. But again, most applications, the one that matter, right, will benefit from this. So if you test this, don't use a micro benchmark, don't use TPS ping. Use the actual application and the workload that is relevant to your actual, core workload. Anyone using AMD here? Yeah, so AMD, depending on how you configure it, you might have more last level cache domains per NUMA node. And that we do not automatically size, right? You can enable the presentation of LLCs to the guest using LLC multi-core per socket equals true, right? For the people that use AMD and that think that their application can make use of that, because for the most part it isn't. LLC size vCPUs, you adjust the size manually, you shouldn't really look at this, I shouldn't have put it there. There's no reason to really use it unless you want to break things. But this is how it would look in the updated slide. You now can also present the topology of the last level cache up to the guest, right? Now, most guests and applications do not really take benefit of the LLC topology. I think I should have looked this up beforehand, shouldn't I, before I came here? But I think Linux 6 actually, the relationship scheduler, takes that into better account than it did before, but I have to verify that. But yeah, that's possible now. Now, what I'm trying to say is some people in the past have said cores per socket, and then basically forced the guest operating to think, hey, cores per socket, that means last level cache domain. Now you can do it separately, but your guest might not be aware. All right, with that being said, there is more to read that you can do by yourself. This is the one that you probably want to take a picture of if you want to read something. We're going to have a series of little videos where we go into some of the individual features that we will publish across GA and a couple of weeks into that. Again, our virtual room is the performance engineering log, and the performance best practices is always being linked to the most up-to-date one at via vmware.com at PBP, and this is where you get the 8.0 version when it is out. Now, please take your survey. Oh, wait, let me ask, are there any questions? Or does everyone want to get home? One question, okay, sorry about that.
Yeah, when you said you almost have the power also doesn't have to be a power. If I have a legacy old VM, do I have to power it down?
Well, you have to power, so the question was if it's only available for new VMs, yeah, you have to power it down and you have to power it back on. And I mean, if you want the new virtual topology feature, you actually have to upgrade the hardware and set the setting yourself. It's only for new VMs. Any other questions before everyone is gone? Yeah, sorry, first there.
So one of the big advantages I see here is I did some performance testing back a couple of years ago.
Bye everyone, by the way, sorry.
Race coding architects like vSphere compared to other vendors that are out there. We're passing NVMe through, so we're driving full line rate of PCI bus. Have you done anything to show the ingress for the about?
Okay, so that's a mouthful. Maybe we want to talk about that later because it's going to take a little bit longer than the 2 minutes we have left. But come to me, please. Any other quick questions?
So what happens if the processor is actually not symmetric? Like, for example, the Alderwood has a performance and efficient cores. So
Yes. So the question was if the processors are not symmetric, if they have efficient cores. We don't care about efficient cores right now. So again, I probably shouldn't talk about this, but again, did the recording stop already? No, it didn't. So I don't know is the answer, the official answer. Any other questions? All right, if you have any other questions, see me after this. We're going to stop the recording, and I wish you all a great rest of the day. Get home safe, and I'll see you next year. Thank you, guys.